So in this case, we are going to quickly rush through the questions that we are given as we are to consider our algebraic expressions. Remember that it is part of your syllabus and you need to work as much questions as you can. Just try to prepare yourselves for the exams that are ahead of time. So we are given on this question, which was actually question number 1. On 1.1, it was for you to factorize the following expressions fully, meaning to say factorize completely what you're given there. So let's consider the first part. That is 1.11 we are given. This is 4y squared minus 16. So be careful as you are working with factorization. Remember the golden rule. If there is anything that is common, that is the first thing that you're supposed to consider. It is very true that this is a difference of 2 squares. 4 is a perfect square. Y squared, the 16 is also a perfect square. Very true. It is very, very true that it's a difference of 2 squares. But are you seeing that before you consider it, 4 is common between these two terms. So you can factor out the 4. So what are we going to have at the end? 4y squared divided by 4, that is going to be y squared. Remember, this term divided to 4. So that is going to be y squared. Minus 16 divided by 4, that's a 4. So we have divided each term, all right? 4y squared, you divide by 4, they cancel. You remain with y squared. The same thing, 16 and 4. This is where you are. Still, this is a difference of 2 squares. We have to factorize completely, which is fully. So what are we going to do? Remember, x squared minus y squared was taken from what? X minus y into the bracket of x plus y from your difference of 2 squares. So as we are to consider this y squared that we are given minus 4, it is same as we've got y squared minus the 4 that we are seeing as a number raised to the exponent of 2 as we have here. It can be written as what? As 2 squared. So this is a perfect square. These two terms are being raised to the exponent of 2, the y that we are seeing, and these two. So we can factorize, as we do understand, guys, the difference of 2 squares. We are going to have 2 brackets. The square roots of these numbers, so it is going to be y minus 2 in one bracket. Another bracket, it is going to be y plus 2. We have a difference of 2 squares at the end. So this is what we have. And you can see that there's nothing common in these 2 brackets. So this is factorized completely. But let's say you did not see or figure out that 4 is common there, then you apply your difference of 2 squares direct. It is still going to work. Okay, let's say this is what you did. You see that 4 is a perfect square. The 16 is also a square. The square root of 4, you know that is 2. The square root of y squared is y. The square root of 16, that is a 4. So one bracket is going to subtract, another bracket is going to add. So this is what you're going to have. But remember, they are saying factorize the following expressions. This expression that you're given fully, meaning to the last extent, completely, you're supposed to factorize completely. Is this fully factorized? No. Because in these 2 brackets, we can see that in this bracket, 2 is common. In this other bracket, 2 is common. So you're supposed to factor out those terms which are common, or the number which is common. So in this bracket, as you can see that 2 is common, we can factor out the 2, meaning to say it is going to give us 2y divided by 2. That's y minus 4 divided by 2, which is minus 4 divided by 2. That's a minus 2. Okay. You move on to this bracket. You do the same thing. Remember, a bracket simply means it's a multiplication. So you're simply multiplying. Here it's a multiplication. The number that you're going to factor out, which is the 2, which is common. It's a multiplication. Remember, it's a bracket. So it must be multiplied to the other one. So you factor out 2. What are you going to have in this bracket? That is 2y plus 4. you divide by 2. 2y and 2, this is going to give us y. 4 divided by 2, that's a 2. So this is what you're going to have at the end. The numbers outside of the bracket, these 2 and these 2, can multiply them together, the outside of the brackets. So 2 times 2, that's a 4. And we have got your 2 brackets, y minus 2 into y plus 2. So as we can see, this is the same answer as what we had before. You just have to be careful. The method or the simplification that you're going to use at the end, you're supposed to be very careful with that one. All right, let's consider another part of our question, which is 1.12. We are given, again, it is to factorize. If you are to consider this, all right, let's see what we have there. 1.12, this is x to the exponent of 3. A given is over x squared plus x plus 1. So here they are just testing you from your normal factorization. Remember the factorization, the difference of 2 cubes. So there we are actually having that. The difference of 2 cubes. Remember, 1 is a perfect cube. 1 can be written, this one can be written as 1 to the exponent of 3. So meaning to say we've got the difference of 2 cubes, x cubed minus y cubed like this. Remember, it is supposed to give us x squared plus xy plus y squared. So this is what we have. There we have got x, and here we've got a 1. So this is what we are going to have. That is going to be x minus y, which is x minus 1. What represents our y value is the 1. So that's x minus 1 into this bracket, x squared. So it is going to be x squared plus xy, which is the product of x, is 1. X times 1 is x, I mean. So that is going to be plus x. Then the last term squared, which is 1 squared, is equal to what? 1 squared is equal to 1. 1 can be raised to any exponent and remains as 1. To the exponent of 2, it's 1. To the exponent of 3, it's 1. So you factorize that. What about the other bracket? What about, this denominator? Can we factorize this? It is impossible. Look, this is exactly what we have here. The x squared plus x plus 1. This is exactly what we have here. So just rewrite that as it is, x squared plus x plus 1. So we can simply divide, because this and this is exactly the same. It can be divided. Remember, this is a bracket, so it simply means there's a multiplication. So here we can also consider it as a bracket like that. So it's this bracket to this bracket. What are you going to remain with? In the numerator, yeah, but this is 1. So it's just like over 1 like this, which simply represents what? X minus 1 at the end. So questions can be like that. Questions can be of this nature. You have to be very, very careful. All right? You have to factorize, then simplify whatever that you're given. All right, considering another question on our factorization, we are given, that was 1.13. 1.13, this is x minus 1 plus y minus xy like this. All right, I think by now you are used to these questions I've been explaining. Almost each and every question paper, we have a question like this, where we've got 4 terms, 1, 2, 3, 4. And I talked of the grouping method, factorization by grouping. So if you are to consider that, you can group your terms to say the part where we've got x, right? But in this case, okay, let's say I take this x and this x here. Let's say, I'm just saying, let's say we do that. Are you seeing that the part that is remaining here, minus 1 and y here, there's nothing common. There's nothing common. So if that one is going to be your decision. Are you going to take x and this one and these two in the middle, or you're just going to work as it is? Because on the last 2 terms, y is common. But our major focus here is that we are supposed to have exactly what is going to be obtained from the first bracket if we group them by, into 2 like this. All right, let me do this so that you understand me. Remember, I said you group your terms into 2 like this. These are 2 terms. This is x, this is minus 1. There are 2 terms. But it's already factorized because there's nothing that you can factor out between these 2 terms. So what is your common factor there? It is 1. 1 cannot affect anything. So x divided by 1, that is x, minus 1 divided by 1, that is minus 1. We haven't changed anything, but we have factored out 1. Factoring out 1 does not affect anything at all. What we just need is to have a bracket and see the number that is affecting that bracket. So it is a 1. Then here there is y minus xy. If you check properly, the part that has got x, it is this one at the end. It is the part that has got x. But if you check on our first bracket here, the part that has got x is the first part here. It is the first one. So you can just rearrange so that you don't confuse yourself. Start with what? Minus xy, so that you do not confuse yourself. So this is the same as we've got minus xy plus this y, this one. All right? You can rearrange. It's allowed. So that you properly see, this is the part where x is the first term has got x, the same as what we have the first term has got x. Remember I said, whatever that you're going to factor out, you have to make sure that the bracket that you have is the same as this one. So it is best that you start with x so that you can properly see what are you going to factor out so that it will be plus x. Are you going to factor out minus y? Are you going to factor out plus y? All right? So you can see, guys, there's a negative here where x is. So for us to have a positive where x is, we're supposed to factor out what? A negative value. Negative gives us a positive. So we're going to factor out minus y. All right, so this is it, guys. So let's factor out and see minus xy divided to minus y. What we're going to have like this, minus xy over minus y. Remember, we factored out minus y. Minus was going to cancel. Y and y was going to cancel. X is positive, as you can see. So that's positive x. Then you move on, y divided to minus y. So y is positive over minus y. So this is it, guys. Positive and negative. That's what? That's a negative. So it will be -1, which is exactly what we see in the first bracket. Once you do this, guys, you won't go wrong because you see that this is exactly your first bracket, x minus 1. This is exactly what you got here, x minus 1. And I said once you see this, you factor out that which is common. The bracket it out like this. You factor it out. What are you going to remain with? If you remove this, if you take this one out, you're going to remain with a 1. And here we are going to remain with minus y like this in another bracket. That's it. We have removed the part of what? X minus 1. So you remain with 1 minus. What is remaining? It's a bracket that you're creating. Just like that, you're done. So let's do revise, guys. As many questions as we can. Also, like I said, the simplification there can be actually done in different ways depending with your understanding. All right, considering question 1.2, simplify the following expressions fully. Again, just like what we had on the previous case, that's 1.21. This is 3 minus 3x. All right, let's see everything over x squared minus 3x plus 2. All right, so definitely factorization has to play a role. If we are to consider, here we can see that there is 3 minus, this is 3 minus 3x. Take note there. This is 3 minus 3x. We do understand, guys, let's be realistic in our mathematics. We do understand that when writing, it is best to start with a term, 2x, like a variable, where we've got a variable, 2x plus 4. It's normal. 3x plus 7. All right? So we can also do that so that we maintain starting with x. So you can just start with the part of it which has got x here, minus 3x. So this is same as we've got minus 3x plus a 3, this one. It remains with the sign as it. Remember the 3, the sign, it is positive 3. Nothing has changed. We're just rearranging starting with x. All right, 2. All right, guys, now we can factorize this part. Let us factorize and see what we can obtain at the end. Minus 3x plus 3. We can factor out a minus so that x remains as a positive. It is easier for us to read x as a positive. So also when writing, it is best that you write your x as a positive value. So for this x to be positive, we must factor out what? A -3. Let's factor out a -3, minus 3 and minus 3. That's a positive. So it's going to be positive x there because it's going to cancel. You remain with x. 3 divided by minus 3. So it's 3 over minus 3. So that was going to give us a -1 because there's a positive and a negative. So it'll be -1. You factor out a negative. Guys, once you expand this, you're going to have the same part that you had before. All right? Let's move on to the other part. The denominator, we are going to have 2 brackets there. So in the denominator, there's a quadratic expression. As we can see, the highest exponent is 2. So we are supposed to expect to have what? 2 brackets. The coefficient of x squared here is 1. So it gives us the advantage to write x here and also write x here. I talked about this. Then you consider the constant, which is 2. Do we have products? 2 numbers that you multiply, you obtain a 6. I mean, you obtain a 2 if you multiply the numbers. But when you add the same numbers, you must get a -3. So there is 2 and 1, a -2 and a -1. We need where we get a +2. Both gives us a +2 when we multiply. But when we add, where are we going to have a -3? That's minus 2 plus minus 1. This one is going to give us a minus 3. So these are the numbers that we want, guys. Minus 2 and minus 1. By doing this, we can see that there's something common between the numerator and the denominator. There's a product, guys. This is simply a product. So it allows us to cancel x minus 1. X minus 1 can cancel like this. So it is going to be minus 3 times 1, which is minus 3 over x minus 2 times 1, which is x minus 2. So this is what you're going to have at the end. And this is in its simplest form. There's nothing that you can do from this stage. You cannot factorize. You cannot do anything. This is what you have. So guys, let's be very, very careful as we are simplifying. Verify, check properly. What is it that I'm given and how am I supposed to factorize such? So the best way, go through your introductions, go through the from your basic, considering the part of your exponents there. You were given, that's 1.22. Let us just have it here. So this was given as 16 to the exponent of minus x times 12 to the exponent of x plus 1, everything over 3 to the exponent of x times 4 to the exponent of minus x, like this. I actually said, if you follow like the way of my explanations, I said it is easier to work with numbers which are in simplest form, like the smallest values, which are the prime numbers. The smallest prime number is possible. Smallest prime number is possible. Yes, we can use any other numbers, but the best is for us to look for the smallest prime numbers, the smallest that we can use. All right, 16 in simplest form as in prime number, 16 can be written back in the base of 2. That's 2 to the exponent of 4. All right, when I'm talking about prime numbers, guys, I'm talking about these numbers, 2, 3. Remember your prime numbers. These are the prime numbers that I'm referring. So 16 cannot be referred to 3 to 5. Yes, you can skip that and write it in the base of 4. But once you use 2, don't consider 4. That is another part of using a 4. If you use like my method, this method of mine, of working with prime numbers, it means you are going to use 2 to the exponent of 4. But it can be any other way. Please do not confuse me there. We do not confuse yourself there. It can be any other term. But here, you can just work with the smallest, which is 2. All right, so 16 being 2 to the exponent of 4, but there is a minus x, which is there. So it was going to be like this, 2 to the exponent of d there. So what are we going to have? It will be 2 to the exponent of 4 times minus x, which is minus 4x. So this is 2 to the exponent of minus 4x. All right, this is on your 16. What about 12? Can we have 12 as a product of its prime factors? Yes, that's 2 into 12, which is 6. 2 into 6, which is 3. 3 into 3, which is 1. Can be written as 2 times 2 times 3. 12, it is same as 2 times 2 times 3, which is same. 2 times 2 is what? That's 2 squared times 3. 2 squared, which is same as 4. 4 times 5. I'm dealing with prime numbers, so I'm going to use 2. But you can use any other number. But as for me, guys, with my method, prime numbers, prime numbers. So this is what you're going to have in place of 12. 2 to the exponent of 2 times 3. But being raised to the exponent of what? As it is given originally there, it is raised to the exponent of x plus 1. This is your 12. Read, it's written in another format. So let's raise, guys. 2 to the exponent of 2 to the exponent of x plus 1. It is going to be written as 2 to the exponent of 2. Remember, you're going to have it like this, 2 to the exponent of 2 into x plus 1 like this. So we multiply 2 times x, which is 2x, exponent of 2x plus 2, times, you do the same thing on a 3. You raise it to the exponent of x plus 1. So that's 3 to the exponent of x plus 1, like this. This is where you are. You have raised everything to the outer exponent, which is the x plus 1. Everything is being as prime numbers. 3 is already a prime number, so we're not going to change anything. Just going to rewrite as 3 to the exponent of x. 4 is not a prime number. Let us have it as a prime number in the base of 2. That is the simplest base. So 4 is same as 2 to the exponent of 2. But being raised to the exponent of minus x, like this. So it will give us 2 times minus x, which is minus 2x. So that's 2 to the exponent of minus 2x, like this. you apply the laws of exponents. Those are our laws that if the bases are the same and we are multiplying, remember you're supposed to add the exponents. Same, we're going to add the exponents. So that is 2 to the exponent of minus 4x plus we add exponents, right? I'm talking about where we've got the base of what? The base of 2. So from the numerator, on the numerator, you add because these are 2, they're under multiplication. So that's plus 2x plus 2. But you're dividing. Look, there's a denominator there. When you divide, what is that you're supposed to do? You're supposed to subtract the exponents. So it was supposed to be minus 2x here, minus 2x, which is going to give us plus 2x, minus. All right, so this is it about the base of 2, guys. We have used the base of 2, then we move on to the base of 3. On the base of 3, it is under a division. You can consider this. There's a 3 here. There's also a 3. This is a direct division that we are having, numerator to the denominator. So like I said, division, you subtract the exponents. So that's x plus 1 minus this exponent, which is x. So take note here, guys. It's now as 2x like this. It is minus 2x. That's why we are having a plus there, okay? But in the actual sense, you were subtracting. All right, so this is where we are. You consider the base of 2 on its own, the base of 3 on its own. So let's simplify collecting the like terms because we can see there's a simplification to be done under the base of 2 on these exponents. Let's consider the like terms. 2 plus 2, that's a 4. So we've got 4x minus 4x, that's a 0 there. All right, so you're going to remain with a 2. So that's 2 to the exponent of 2 times, so it's going to cancel. You remain with 3 to the exponent of what? Of a 1. So this is what you're going to have at the end. 2 to the exponent of 2, which is 4, then 12 at the end, just like that. So questions can be like that. If you are working with this part of simplest form, where you write your numbers in simplest form, you are not going to have any challenge. But guys, this is mathematics. Once you get your mathematical view of the question, it does not matter that you follow what I say or you follow what another person say. As long you have a mathematical view of what is happening there, you can use any approach. Instead, you could have ignored that writing as prime numbers because you can see something just writing in simplest form. It is also about not be written in the same. If there is a possibility of that one, do it. The 16 we can see it can be written in the base of 4. So it means there's no need for us to be changing the 4 to 2, this and that. We can use the 4. It can be like that. This 16 here can be written in the base of 4. So 16 is same as 4 to the exponent of 2. That's 16. 4 to the exponent of 2 being raised to the exponent of minus x as we are given. So it will be 4 to x. Since we have used a 4, as you are to expand this 12, expand it using the numbers that are given there. There's a 3, there's a 4. So can 12 be written by any means of these two numbers, 3 and 4? Yes. 12 is same as what? 3 times 4. It is same. It is the same thing. So instead, we can write it like that. But being raised what? Remember, it was already raised to a certain exponent, x plus 1. Meaning to say every number will be to the exponent of x plus 1. The 4 also will be raised to the exponent of what? Of x plus 1. Each and every term that you're given. All right, the exponent of x times 4 to the exponent of minus. Like I was saying before, we are back now to the same condition, having the bases which are the same. In the numerator, we can see that's a product. We've got the base of 4 here, got the base of 4 here. So what are we going to do? We add the exponents because it is under a multiplication. So it is going to be 4 to the exponent of what? Minus 2x. We add this exponent as it is. So that's plus x plus 1 like this. This is the base of 4. But as you can see, we also have another 4 in the denominator. Meaning to say it's a division, this one. When the bases are the same and you're dividing, what are you going to do? You're supposed to subtract. So it was supposed to be like this. It was supposed to be minus x like this. But guys, what is minus x? Minus and minus gives us what? A positive. So instead, you can just write it as what? As plus x. But the actual thing that happened is that we subtracted this. So minus and minus, it's a positive there. Please be careful. All right, let's move to another stage considering the 3. There is 3 here, there's also 3. The bases are the same, so the condition is not going to change. What are we doing? What is it that is happening? The 3 on its own here, how is it affected? It is affected by what? A division. This is a division, we are dividing. So if you are dividing, check to this exponent, so it's going to be minus x. That's it. Okay, so you can simplify further from there. So meaning to say, what are you going to have? considering your like terms, this is 1x. So this is 1 plus 1. Okay, sorry, 1 plus 1, which is 2 minus 2. So this was going to cancel the part of x. You remain with what? With 1. So that's 4 to the exponent of 1. Here, that's a 0. So you're going to have a 1. So that's 3 to the exponent of a 1. 4 to the exponent of 1 is same as 4. 3 to the exponent of 1 is same as 3. So if you multiply 4 times 3, what do you get? A 12. Same answer, just like the previous one. So questions like these, they are just testing you guys. The simplification, guys, under exam, it is now in your hands. As we have got the basics that we can use to say, for all of us to understand, let us just use one base, which is the base of 2, use the simplest form. It is just something that we want you to understand, not to say it is a formality that you're supposed to follow each and every time. No. If there can be an easier way or another format, guys, follow for that one, as long as you understand it. If you do not, then use the exact way that you have been using before, the exact way that you have been applying before, if that is the one that you're understanding, please. All right, let's consider another part, which is 1.3 marks, okay? So this is 3 marks. Given that m is equal to, all right, them questions, they'll be testing you something here. So it is equal to x into x minus y squared. That is what they are giving you there. And they are saying, determine the value of m. Here it is for you to determine the value of m if. It's a condition that when you see it, when you see xy squared, you're going to put a 4. When you see x cubed minus 2x squared y like this, you're going to put a 3. But are you seeing it so far? Yeah, initially from what you're given, are you seeing it? Are you seeing xy squared? No. Are we seeing x cubed? We are not seeing it from this. We are not having it. It's not there. But they're saying this is what we are supposed to substitute. So where are we going to substitute it while it is not there? It means it is hidden somewhere here in these brackets here. These terms or these expressions that we are given there, they are there, only that being hidden out of these brackets. So let's expand the brackets first and figure out. So m is equal to x into what? If you expand this bracket properly, it's going to be xy squared. Remember, guys, I talked about expansion when you're given to exponent of 2. Or you can have 2 brackets. If you've forgotten, guys, you 2 brackets, x minus y into x minus y like that. You expand your brackets and collect like terms x times x, which is by form method x and minus x, x and minus y here. That's minus xy, minus y and y. There's going to be y squared. You collect your like terms minus 1xy minus 1xy is what? Minus 2xy plus y squared. This is what you have. You can do that. If you know this expansion when raised to the exponent of 2 like this, guys, just expand by the x, which is outside of the bracket. We can see that there's an x which is outside of the bracket here. So x times x, that is x cubed. Let me just put it this way. X times x squared, which is x cubed. X times minus 2xy. You're distributing, remember? So it is going to be minus 2x squared. The x and x is going to be x squared. And we're going to have y there. Then x and y squared. So it is going to be plus x y squared. So this is it. You have expanded. This is what you have done. The brackets, which is exactly according to what you're given, you have expanded your brackets. So this is it. They are saying where you see the xy squared, you're going to replace it with a 4. Are you seeing it? Yes, it is there. Xy squared, here we have it. So this part of xy squared is going to be replaced by a 4. Where you see, that is what they're saying, where you see x cubed minus 2x squared y like this, you are going to replace it with a 3. Are we seeing this x cubed minus 2x squared y? Are we seeing it? Yes, we can see it here. X cubed minus 2x squared y here. We can see it. They're saying substitute those with their equivalents. So it means m is equal to this whole part that we are seeing here. They are saying it is equivalent to 3 according to what we are given here. It is equal to 3. So we're going to substitute a 3 in place of that. A numerical value plus, as you can see, there's a sign there, which is addition. So we're going to add xy squared. Where we see xy squared, what are we going to put? Xy squared, we are going to put a 4. So this is plus a 4 like that, just like that. So this is it as 4, that is a 7. So m is equal to 7 as we are expanding these brackets in this way. So let us revise, guys, as many questions as we can. Anything on your algebraic expressions, They want you to know, they want you to actually have the basics. Know your factorization, your simplification, expanding of brackets, and any other simplification that can be given. For you to know this, it is by revising as many questions as you can, revising as many question papers as you can. So this is it. This is it. Let's revise as many question papers. Just try to figure out how do they ask these questions. That's it. Till we meet again.